Hey guys, so today what we're going to be looking at is parabolic transformations. So the grade level for this lesson is going to be high school algebra, and I'm not going to be showing this, but I put an activity that is like an extension of this in the Explore More on the handout that I gave you, and it's just kind of like a very basic intro to like finding the area under the curve. Also, the Ohio Standard will be build new functions from existing functions. Then the goals and objectives will be to identify the effect on the quadratic graph by replacing A, B, and C with specific values. Experiment with cases and illustrate an explanation of the effects on the graph using technology. So the academic language is going to be parabola, which is a symmetrical open plane curve which graphically represents a quadratic function. So it's going to look like a U shape. And then coefficient, which is a constant quantity that is multiplying the variable in an algebraic expression. So for example, y equals 2x plus 1, the coefficient of x would be 2. Then quadratic function, which is a polynomial function of one or more variables with the highest degree term being of the second degree. So, for example, x squared plus x plus 1 would be a quadratic function. And we're going to be looking more at the quadratic functions and their graphs today. Then the language function is discovering what the function is of each coefficient in the quadratic function and exploring how the changes in the value of the coefficients transforms the whole graph. So what we're going to be doing today basically is graphing quadratic function and just kind of seeing how each coefficient affects the graph and how it changes. So this is the final product of what we are making. So we're basically making a parabolic transformer of sorts. So I made these sliders, so we're going to be able to see exactly how each coefficient affects the graph as it changes. And yeah, so let's do it. So the first thing we're going to do is you're going to go into your segment tool, and you're going to make 3 different line segments. They don't have to be all the same length, but it's kind of nice just so that when we do our when we make our transformer later on, that they'll all be the same length, and so the coefficients will be changing at the same pace. Okay, so we're gonna just work with one for now and just kind of like put the rest of them off to the side. Okay, so the first thing you're gonna do is you're gonna label each of the endpoints A and B. And then construct a point on one, like anywhere on the segment. It doesn't have to be in the middle or in a specific area. And then label it C. Okay. The next thing that we're going to do is we're going to find the distance from A to C. So you're going to click on the point A and then on the point C and go up to measure and calculate the distance. And so it'll just give you it right there. And then you're going to do the same thing from A to B. Okay, now that we have our distances, we're going to evaluate the value of A. So this is going to be our A coefficient slider. So first thing we're going to do is we're going to go up to number, click on calculate, and you're going to type in, do parentheses, and then click the length of AC divided by the length of AB. And then it'll already automatically put a parentheses there for you. And then times 20, and then minus 10. And so the reason we do times 20 minus 10 is we're setting our parameter from negative 10 to 10. So we're timesing it by 20 because in total there's 20 values there that A could be. Like the parameter has 20 values in it, and then minus 10 because we want our parameter to be from negative 10 to 10. So that gives us our endpoint quantities. And then you just click OK, and that will give you the value of A. So we want to kind of make this look a little nicer. So we're going to click on points A and B, go up to display, and then hide points. And then you're going to double click on C and then just change this label to A so that we know that it's A. And then, yes, and then we're going to click on this, do display, and click label measurement, and then you're also going to label that as A as well so that we know that this, when we move this, that this measurement is A. And yeah, so just like move your slider back and forth to make sure that it goes, that the highest value is 10 and then the lowest value is -10 as well. And if it's not, then you may have to go back and switch some things around. You might have made a little bit of a mistake. That's okay, just go back and fix it. And then we want to hide these as well because they're not important anymore. And then, so yeah, so click on both of them, do display, and hide distance measurements. So okay, so we have our A, so we can move that up here. And then we're going to just do the same exact thing for all the rest of them. This one's going to be our B, and so you're going to label the endpoints D, E, and then F, and label that F. All right, and then we're going to find the distance again from D to F. So click on both points, do measure distance, and that'll give you your distance, and then again from D to E, do measure distance. Okay, and then we're going to do the same thing again, calculate and do parentheses, df divided by de times 20 minus 10, and this will give us our value for B. So click DE, hide the labels, and then change F to B. Hide these, hide the distance. Oh, make sure to deselect everything before you do that, or it won't give you the option. So we want to hide distance measurements, and then we want to change this label to B. So label measurements, B. Okay, and then you can put that next to the slider so that you know that it is the B measurement. Okay, and then we're going to do this one more time for the C value. So go back to your label and label it G and H, then construct a point somewhere on the segment, and label that I. Alright, now click on G and I, find the distance of it, and then the same thing for G and H. Measure, oh, make sure to deselect GH distance. Okay, and then we're going to calculate it again. So parentheses, GI divided by GH times 20 minus 10. Okay, so we have our C value now. We'll go in and hide the labels, and then change this to C. And we can hide these distance measurements. And one more thing, and then we are set to go. Change this to C. Okay, so we have our sliders and we have our values. So the next thing we're going to make is our graph. So the first thing we want to do is go up to graph and do define coordinate system. And so you should see coordinate system. You can change the window if you'd like. Excuse me. I'm going to leave it like this. Yeah, so then the next thing we're going to do is go up to graph again and do plot new function. Alright, and we're going to make a quadratic function. So when we do this, we want to put it in the quadratic function form. So for A, you're going to click on A. So do A and then times X, caret, and then click on 2. So we have A times X squared, and then we're going to do plus B, click on B, times X, and then plus, and then click on C. So when we plot this, we'll be able to manipulate the values of A, B, and C since we use those values to plot our function. So, and then once you have that typed in, just click OK, and you should see your graph there. And I'm going to make this a little thicker just so that I can see it better. So display, line style, thick. There we go. Okay, and then I just want you guys to see sort of how like each coefficient manipulates the graph. So go ahead and just kind of like play around with the sliders to see how each coefficient changes the graph. Yeah, so it's looking like A is makes the graph wider or thinner, depending on what the value is. Let's look at B. So if we slide B, it looks like it moves the graph side to side. And then C moves the graph up and down. Yeah, so this is just a really good tool to kind of see how each coefficient is affecting the graph and as it changes over time. Okay, so now that we have our sliders and we've experimented, explored a little bit with them, we're going to animate them to see how they all affect the graph at the same time. So what we're going to do is we're going to click A, B, and C. We're going to go up to Edit, put your cursor over Action buttons, and then click Animation. So when I was making this, I experimented a little bit with the different speeds, and I found that the slow speed actually works the best because you can really see how it's changing the graph. And so just go into each one of these options and just change the speed to slow. Yeah, I found with medium speed it was a little fast, and you couldn't really see how the graph was changing. It was just kind of like this really sporadic sort of graph. So change everything to slow, and then yeah, make sure it's on bidirectional and click OK. Alright, so we have our button. I just want to move it over here so that I can look at it better. There we go. Okay, so you want to change the name of it to Transformer. So you're going to highlight it and then do Display, Label, Action button, and then change it to Transformer, or you can change it to whatever you want. I'm going to do Transformer though. Click OK. Alright, and then let's see. It's kind of nice to have everything start at 10. So let's move all of our coefficients over to 10. And then click Transformer. Yeah, so it's kind of cool to see how each coefficient changes sort of at the same time too. Since we started them all off at the same place, they're changing in real time. So one of the things I kind of want you guys to experiment with is to change like the different the displacement of each coefficient. So B could like start at 10, A can start at 0.88, C could start in the negatives. Just kind of like play around with it and see how the different coefficients affect the graph in different ways. And one thing I did notice was when you have B in a different place than the other coefficients, you can really see how it's affecting the graph. Whereas when it's all when they're all in the same when they all have the same placement, they're all moving at the same time, you can't really see how each coefficient is really affecting the graph. Yeah, so I hope you guys learned a lot. Take a look at that, explore more, and just have fun with it.